A particle's velocity is given by, the velocity is 3t squared minus 5t plus 2. The function x of t represents the position of the particle along the x-axis. So we have the velocity, we need to find the position. We're going to integrate, baby, find the position of the particle after 4 seconds. Given the initial condition at 0 seconds, we're at 10 for the position. So let's integrate straight up there. So we're going to have the integral of v of t is going to give us our position function. All right, so we're going to integrate 3t squared minus 5t plus 2 dt. Okay, that is going to be t cubed minus 5 halves t squared plus 2t plus c. All right, so that is going to be our our position function. Now that arbitrary plus c has got to remain there because we have two parts here. Part A says, all right, well, let's get the initial condition 0, 10. So I have to find c, given the fact that I have t is 0 and I get 10. So we're going to set this equal to 10. That's going to equal 0 cubed minus 5 halves 0 squared plus 2 times 0 plus c. You go away, you go away, you go away. Okay, so in this case, 10 is c. Now that I know that, I can rewrite this equation here and say my position function, x of t, is going to be t cubed minus 5 halves t squared plus 2t plus c. Now I care about what happens at 4 seconds. So x of 4 is going to be 4 cubed minus 5 halves 4 squared plus 2 times 4 plus 10. I don't know why I put plus c there. It's plus 10. I just found out that it was 10. Why did I do that? Plus 10. Plus 10. Okay. You're 64 minus 5 halves, you're 16, you're 8, you're 10. 64 minus 40, yep, 40, plus, we'll just combine these, 18. 64 minus 40 is going to be, what is that, 24? Why did that take me so long? 24 plus 18 is going to be 42. And where are we? Where are we? Where are we? Seconds, do I have feet? Do I have feet? Do I have feet? I've got nothing. So 24 units or whatever. 42 units. 42 units. Okay? Cool. Now we got to do this again, and this next one's going to be a little bit more complicated because we're plugging in 1 to get negative 1. So negative 1 is going to equal that guy with 1 plugged in for t, 1 cubed minus 5 halves times 1 squared plus 2 times 1 plus c. So negative 1 is going to equal 1 minus 5 halves plus 2 plus c. Negative 1 is going to equal, what is that, 3 minus 2, so that's 2.5, so 1/2 plus c. Subtract a half, and we're at negative 3 over 2, plus c, equals c. So now I'm going to use this equation, or this equation rather, but replace the c with negative 3 over 2. So that's my new function. This isn't going to be exciting at all. X of t is going to be t cubed minus 5 halves t squared plus 2t minus 3 halves. X of 3 is going to be 3 cubed minus 5 over 2, 3 squared plus 2 times 3 minus 3 over 2. 27 minus 5 halves times 9 plus 6 minus 3 over 2. Let's move that up here. Let's move that up here. Let's move that up here. 27 minus 45 over 2. 6 minus 1.5 is going to be 4.5. So let's turn that into 9 over 2. So minus, right? 4.5 is 9 over 2. 27 minus 54 over 2 is going to be 27 minus 27. Get out of here. No way. All right, so we didn't really move anywhere. We didn't go anywhere after all that. Or that's where our position is. Our position's at nothing. Oh, that's fun. All right, well, that took a while, but boy, did we have a great time doing it. A ball is thrown down off of a house with a velocity v of t equals negative 32t minus 8, where t is time in seconds and v is feet per second. The ball is 20 feet in the air at time t equals 1, which is the initial height of the ball. So in order for me to find the initial height of the ball, I need to integrate v of t dt, right? And that'll get me that height. So we'll say h of t, okay, for a height over time. So let's integrate this, right? We're going to take the integral indefinite of negative 32t minus 8 dt. That's going to get me negative, what is that, 16t squared minus 8t, which looks about right because that's a typical gravity-looking formula right there. All right, plus c, we can't forget that. Now we're given this initial condition that when t equals 1, I get 20. So I have to find c by plugging in 1 for t and setting it equal to 20. So 20 is going to equal negative 16 times 1 squared minus 8 times 1 plus c. 20 is going to equal negative 16 times 1, which is negative 16, minus 8 plus c. 20 is going to equal negative 24 plus c, add 24, add 24, and you get 44 equals c. So the height formula is going to be h of t equals that guy, but replace the c with 44. So that should be h of t, not h of 4. Don't know why I put h of 4 there. So let's erase it. H of t is going to equal negative 16t squared minus 8t plus 44. Now, my job is to find the initial height of the ball, which means when time is 0. So h of 0 is negative 16 times 0 squared minus 8 times 0 plus 44. Adios, goodbye, and h of 0 is 44 feet in the air. And the answer is C. Mr. Anderson leaves for a trip at 2 p.m. and at 2 p.m. the time is t equals 0 and drives with a velocity of 50 minus 1/4 t miles per hour, where t is measured in hours. Find the integral from 0 to 3 of v of t dt. Okay, I can handle that. Very simple, very straightforward. Doesn't seem like a chapter 8 type problem, but I can handle it. The integral from 0 to 3 of 50 minus 1/4 t dt. So let's integrate that. 50 becomes 50t. U become minus 1/2 t squared, and my limits of integration are still going to be 0 and 3. Okay, so let's plug that in. 50 times 3 minus 1/2 3 squared minus 50 times 0, noish, minus 1/2 times 0, noish, squared. U will go away. How nice. U become 150 minus 1/2 of 9, which is going to be 150 minus 4.5. We'll leave it as decimals here because why not? 145.5. And that's going to be stuff that happens. That's going to be his distance traveled after, what, 3 hours? Or at 5 o'clock, this is where he is. So he is at 1.5 feet? Miles? Doesn't say. Miles. Yeah. Pretty straightforward. The graph to the right shows the velocity of an object moving along the x-axis over a 5-second period. If the object started 2 meters to the right, where is the object after 3 seconds? So this is the velocity function, All right, and here it's asking us where stuff is, distance, and where stuff is. So what I really need to focus on is the derivative of the velocity. Okay, not the derivative, the integral of the velocity. Now, what that means for us here is if this is the velocity function and I don't have the actual function itself and I really don't feel like trying to find the piecewise function that matches that guy, what I can do is I can use the fact that, look, the integral is just the area under the curve. So let's use that information. If the object started 2 meters to the right, you're already at 2. Where is the object after 3 seconds? Well, we care about the integral from 0 to 3 of v of t dt. Now that means the area underneath the curve from 0 to 3. So the area here is going to be 1 block, 2 block, 3 block, 4. Easy. This is a triangle with base of 1 and height of 2. So 1/2 of base times height is going to be half of 1 times 2, which is half of 2, which is 1. So I get a full guy here. So u are the same as saying 2 plus 5, which is 7. So we are 7 units wherever that's supposed to be to the right. Okay, I'm assuming that we're still 2 meters to the right, so let's keep that 2 going on there. Where is the object after 5 seconds? Well, we're going to do the same thing. Now this, we just found out that this guy right here is 5 in the positive. Okay, everything down here is going to be negative. So if u were 1, that means this chunk right here is going to be -1, and this chunk right here is going to be -2. Okay, so 2 plus the integral from 0 to 5 of v of t dt is going to be 2 plus that +5 plus that -3. 2 plus 5 is 7, 5 plus -3 is 4. 4 is going to be my answer there. Now to find the total distance, okay, is not displacement. This was displacement. The total distance is the fact that if I were to drive forward 5 feet and back 3 feet, that's still 8 feet. So I have 2 that I started out with, plus the 5 that I drove forward, plus the absolute value of the -3 of me driving backwards is going to be 2 plus 5 plus 3, which is going to be 10. Okay, so this problem was very different, but I kind of liked it. It was fun. A particle's velocity is given by v of t equals 3t minus 10, where t is measured in seconds, v is measured in feet per second, and s of t represents the particle's position. So we are going to do something along these lines, ladies and gentlemen, and integrate v of t to get s of t, easy peasy. So if s of 0 is 5, what is the value of s of 4? So this is what we have to do. We have to integrate that guy right there. Shouldn't take too long. And I'm not even going to do that for part A. I'm just going to do that in general because we're going to need that to do part B as I'm looking ahead. So the integral of 3t minus 10 dt is going to equal 3/2 t squared minus 10t plus some arbitrary c. I have to leave that lingering. Now part A, I have to find out what c is because it's giving me this initial condition that when I have 0, I get 5. Okay, so I'm going to set it equal to 5 and say 3/2 times, let's replace t with 0, so 3/2 of 0 squared minus 10 times 0 plus c. Nice, c is 5. Now that's not me being done. That's just me saying now I have myself an integral, c is going to be 5. So if I have my position function, if s of t is going to equal 3/2 t squared minus 10t plus 5, I can easily find out what happens when I substitute in 4. So s of 4 is going to equal 3/2, 4 squared, a fun game, minus 10 times 4 plus 5. 3/2 of 16 minus 40 plus 5 is going to be, what is that going to be? It's going to be 24 minus 40 plus 5 is minus 35, and 24 minus 35 is negative 11. So I am, according to this problem right here, I am negative 11 feet backwards, okay, at 4 seconds, or 4 seconds, okay. Now that is part A. A is done. What is the value of S of 4? Dunzo. Now what I have to do is I have to do part B, which is asking for the net change. That's the same exact thing as displacement. Okay, so since I already found the integral, normally displacement would be found by integrating between 0 and 6 of that v of t function, right? But in this case, all I have to do is, since I found out what that is s of 6 minus s of 0. Okay, we found our s, we did the plus 5 thing, and so that's going to end up being s of 6 is going to be 3/2 6 squared minus 10 times 6 plus 5 minus 3/2 of 0 squared, how nice, minus 10 times 0 plus 5. So you'll go away. That's going to be 3/2 of 36 minus 60 plus 5 minus 5. So you guys in time will go away. So 3/2 of 36, which I should be able to do right now, 18 times 3 is 48. 48 minus 60 is going to be negative 12. So at the end of the day, we are 12 feet behind where we started. I heard of putting a good foot forward, but 12 feet backwards? Well, that's no good. And it is in feet, isn't it? It is in feet. Thanks for watching.